Hello everyone, welcome back. Now today I'm gonna work on a setup on a new sensor that is MXC6226XU. To have a knowledge about this sensor and to see it, let's have a look over the website controleverything.com and here search for the relevant sensor that is MXC6226XU. Now as you can see, this sensor is a digital thermal orientation accelerometer. It's a 4-position orientation detection and shock survival greater than 50,000 G fully integrated thermal accelerometer, and a lot more features are being provided as you can see. Now you can purchase the sensor from the website and here it is. Furthermore, I will be interfacing the accelerometer MXC6226XU with a BeagleBone Black, and a C code will be required. And to get your hands on the code, let's go to the source tab, and here we have the C code sample onto the screen. Now, as you know, we gonna download the code as a zip file from this very site, and also have the option to get the code from github.com, and the repository there will be Control Everything Community. Now let's have a look over the interfacing part, working part, but before that go to the connections part, the hardware connections. Well, for the hardware connection setup, the first thing we require is the BeagleBone Black, which you are able to see on my screen, and this here is an I2C shield for the BeagleBone Black. Now this is available on the website controleverything.com, and the real reason we are using this shield is to make connections easier with other I2C devices. So for that, what we require is to gently place this I2C shield over the BeagleBone Black and make a connection just like that. For the power up setup, we require two things. The first is a mini USB cable just like this and gently insert it over here. It is very useful to power up the BeagleBone Black. Now to power up the I2C shield, we require a 5-volt adapter, which you are able to see on my screen, and gently insert it in here. Now for an option for the internet connection, there are two mediums. The first is an Ethernet cable or a LAN cable, and the second is this, a wireless nano USB adapter. This here is our sensor that will be accelerometer MXC6226XU, and this here is a connecting cable. Now make the connection among the sensor and the cable, and make sure that the ground terminal of the sensor should be connected to the brown wire of the cable, and similarly to the ground of I2C shield. Now we are done with the hardware connections part. Now let's have a look over the code. Now let's have a look over the interfacing part, and to get there we need to log in to github.com, and after that we have to search for the repository that will be Control Everything Community. Getting there, we have to search on for the sensor that will be MXC6226XU, and here we are with the sensor, and this comes the C code. But before that, let's have a look over the instructions part, and here we need, first of all, we need to set up our BeagleBone Black, and the steps are provided on this link, beaglebone.org. Let's open it up and let's see what we got here. We need to use some drivers here, some connections here. Please do it carefully. After getting this, we need to download or pull the code on BeagleBone Black, and this command will compile and this will run the C code. Now get back to the C code, and it's a C extension file as you notice, and first thing you see into code that we have included some of the header files and the libraries. And in void main function, we have created an I2C function which will check whether the I2C bus is open or not, and whether here it will check the address of the sensor is 0x16 or not. Then in the writing section part, we are going to select first of all detection register that will be 0x40, and the command we are sending here is for power up, which will be 0x00. The writing command is here. Then we have a delay, a sleep function of 1 second, and then we have a reading section in which we are going to read 2 bytes of the data from the register that will be 0x00, and here is the command. And after that, as you notice, we have the conversion of the data. We have the conversion for x-axis and y-axis, and at the end of the code we have the output data onto the screen, which is exactly the raw value for acceleration in x and y-axis. So this is how the code looks like. Now let's see how it works. Now coming to the very interesting part, which is to show the practicality of this accelerometer sensor, we need to copy the entire code as you can see, and after that we need to go to the terminal we have connected for the BeagleBone Black, and here we need to create a new file as you can see on my screen, and it's a .c file, let me tell you, and here we have to paste the entire code, and after that we have to save it, and the command for the compilation. As you can see on my screen, it's this .c will be the file, and after that this is the whole command we need to follow through it. And let's see what we got here. The code has been compiled successfully. Now for the working part, this is the command we need to go through, and let's see what we got here. We have acceleration in x and y axis. It's reflected. It is the raw value. When I again run, the values are same, but when I try to move the sensor in different directions, we can have the value changes, and acceleration in x and y axis, the change is reflected onto the screen. So this is how the sensor works. Now what we're gonna do is to look over the applications and some of the benefits. Let's have it. The sensor MXC6226XU is a MEMSIC digital thermal orientation sensor. DTOS is the world's first fully integrated orientation sensor. Its operational is based on the patented MEMS thermal technology and is built using a standard 0.18 micrometer CMOS process. DTOS contains no moving parts such as a ball and thus eliminates field reliability and repeatability issues associated with competitive products. It also eliminates the click sound typically heard in all ball-based orientation sensors. Shock survival is greater than 50,000 G. So due to these features, it's applicable like applications which are cell phones, digital still cameras, digital video cameras, LCD TVs, toys, MP3s, MP4s, fan heaters, cooling fans, and a lot more. Well, you can have this sensor and you can purchase it from controleverything.com, and you can get the code from resource tab. From this site, you can download the code as a zip file. Also, you can get the code from github.com, and the repository there is Control Everything Community. In the end, I would like to make it clear that if you have any doubt regarding any part of this sensor or video, you can have your queries on controleverything.com, and you can post your comments on the community page on this website. For articles and blogs, you can have a look over on instructables.com, and to subscribe more video tutorials like this, you can have a look over our YouTube channel. In the end, I hope you enjoyed this video and had a good one yourself. Thanks a lot for watching.